Good evening and welcome to Shop Talk, hosted by the Triangle Area SQL Server Users Group. So if this is your first time in chat, obviously it's not Andrew's first time, but this is Andrew's first time back since spending a lot of time becoming a truck driver, having played Euro Truck Driver Simulator for enough hours to become officially a truck driver and then say, I'm just going to drive to Europe and become a truck driver, and then he started exploiting it. It's the farmer simulator. It is true. Farm simulator, real world. The graphics aren't quite as good, real world, but you know it's okay. 6 out of 10, definitely 6 out of 10 score. Maybe a 7 if you get the DLC, the milking cows DLC, but you have to pay extra for that. So welcome to Farm Talk. Welcome to Farm Talk, where we just talk about farm stuff for an hour. So it is a lot harder in real life. You are absolutely right. It's not just like press the A and B buttons repeatedly to milk this cow. There's technique. There is technique involved in milking cows. I have never milked a cow. I may go my entire life without milking a cow. Despite that, I realize that there is technique. And I will not denigrate anybody who has that technique, who has that capacity, even if that capacity is as much as sticking equipment on to perform the milking. Because farmers don't have to go milking individual cows directly. Computers in the cockpit of the combine. Those are some pretty fancy equipment. There's a lot of very fancy equipment in those combines. I know that we've talked about it on previous episodes of Shop Talk, so Shop Talk aficionados can go back into the archives and try to find all of the instances in which we have talked about farming equipment, combines. Some of it was tied in with right to repair, I'm sure. But ultimately, welcome to Shop Talk, everybody. The idea of Shop Talk, which is very different from the implementation of Shop Talk. The idea of Shop Talk is every other Monday we get together. It's after work. We're kicking back. We're relaxing a bit. And we're going to talk a few technical topics. We've got some ideas of things to cover. But this is also an open Q&A. If you have questions, if you have thoughts about, hey, these people on camera, they are experts because they're on cameras. And some of them have very bright lights shining in their faces, which is how you know somebody's an expert. See, Mala's got a very bright light shining in her face right there, so she is an expert. Expertise level went down, but it was up just a moment ago. So we have dynamic expertise levels, but we can answer questions. Sometimes we'll even give correct answers. Speaking of correct answers, I have with me the one and only Mala. So how are you doing, Mala? Your audio is not coming through anymore. The expertise level went up so high that Mala is no longer able to speak with us. She can only use telepathy and beam thoughts into our minds. So while she's working on that, our other hosts are very busy doing other things, of course. Tracy, as we all know, is responsible for repairing every undersea cable in the world. So she's been very busy doing that. And Mike has been damaging undersea cables. I'm pretty sure they have some sort of system going. Good thing I've got my tinfoil hat on. That's actually a pretty solid idea. Make sure to get the barbecue tinfoil because it's thicker, so it helps deflect the beams more effectively. So don't get your low-end bargain basement aluminum foil. You got to get the real heavy duty stuff that they use for barbecue. That pro tip brought to you by Shop Talk. Let's see if your audio is working any better, Mala. No, I don't think so. So, all right. Well, while Mala is disappearing, possibly to cut and or splice undersea cables, along with Mike and Tracy, we have topics. Now, of course, if you have questions, if you have thoughts, they don't have to be related to these topics. Anders knows that for sure. But maybe you've got a question. Maybe you've got a technical question that you might be asking for some advice on, especially if it's broad. Hello, here to participate. Welcome in. Welcome in. So I'm still in my rambling opening phase of Shop Talk. All we're here to do at the moment is have a little chat. We've got some topics that are going to come up in just a moment. We've got a couple of topics of discussion. But also, if you have technical questions, data platform world related. That's what we're here for. So while Mala tries to get everything sorted in, I am going to see if I can share my screen here. So let me... currently running SQL Server 2017 to 2022 with in-place upgrade. 0 prep or work. Good idea or bad idea? Roll it. Go for it. Everything will be fine. Actually, bad idea because you gotta get SQL Server 2025, which
Can
happens.
you hear me?
Yes, and
But suddenly I have jaundice. My face looks yellow.
little bit of that and a different camera angle. So we now have Mala from camera 2.
Okay, but go on.
All right. So topic number 1, topic the first. SQL Server 2025, by the way, has gone to RC1. Not too long ago, it was RC0. I won't be going to 2022 AI edition anytime soon. There are some pretty decent non-AI bits of functionality that have been added in SQL Server 2025. Mostly around regular expressions and some other niceties to the T-SQL names language space. But RC1 fixes some known issues and introduces feature improvements. You say, wow, these 2 lines, they're very descriptive. And I'll say, well, they're categories, so, there's more. Regular expression is why I'm not going to it. Okay, so Anders is not going to allow his developers to tank queries by writing complex regular expressions when they could write it in ways that don't tank a system. How dare you, Anders? Oh, hey, in-place upgrade fails due to replication. So don't try to in-place upgrade SQL Server 2025 RC0. Try RC1. And there were polybase component failures related to encryption. Now, what exactly this was, who knows, because this is all you get. Feature improvements. See, it's not just AI. There's also Linux. There's Linux, Anders. Supports Red Hat 10 in preview. Also supports Ubuntu 24.04. So that's... I don't know if they're going to backport... 2204 to support, or excuse me, 2404 to support SQL Server 2022. They may just force you to 2025. All 2 users of Polybase hit by a bug. I have, for the record, I have spoken with at least half a dozen people on this planet who have used Polybase in production. I have spoken to at least like a dozen who have used it at all. So I would like you to retract your statement. I would like you to put out a forthright apology and be clear that at least 6 people use Polybase. Learn SQL in my full stack web dev bootcamp. Hope to learn from presentation and Q&A. Yeah, so today we're not going to have any fancy presentations. Mostly it's going to be a lot of snark, a little bit of sarcasm, and there will be some questioning, especially one of the articles. There will be plenty of questioning the article. But tomorrow we do have a presentation, and we'll talk about that near the end of the show here. So this is definitely if you have specific questions, specific thoughts, things that, hey, I'd like to learn a little bit more about this thing, especially if it's something that Mala and I can kind of freewheel, then we can happily take questions. Otherwise, think of it as more of extended water cooler talk. So that's our idea of shop talk. It's water cooler talk after the water cooler day is ended. Unless you're on the west coast of the U.S., in which case you're still in the middle of the day, and I'm actually surprised that you're able to watch this, but I appreciate watching this. Anybody who's slacking off at work, remember, this is career building. It is professional development. So you can spend time professional developmenting here with us. There are, as well, these feature highlights. However, this is mostly all the stuff that's just SQL Server 2025 in general, and including things like fuzzy string matching that I think may not. I don't know if they're going to make the main release or change event streaming. It's preview features. I wonder if this is going to make RTM, but nonetheless, that was SQL Server 2025 RC1. The big deal with RC1 is I think it released about 2 weeks earlier than I would have expected. Because I've gone through the entire year, again, with no public information. I know I have zero public information on this, but the expectation that Microsoft is probably releasing SQL Server 2025 to coincide with Build, which is going to be late November. It's like November 18th, somewhere around there. Maybe past Summit the week before, but they're probably holding off for Build. Or Ignite, excuse me, Ignite. I always confuse Build and Ignite. Build is the one in May, Ignite is the one in November. And so Microsoft Ignite, November 18th through the 21st. Well, we had our first release candidate of SQL Server 2025. It was, mid-August, mid to late August. And then this RC came out, has an RC2. A lot of the time they go RC0, RC1, prod, RTM. Sometimes they go RC0, RTM. I think they did that with 2017, if I remember right. Every once in a while, they will do RC1, RC2. I don't think I've ever seen anything bigger than an RC2. So they've had 3 release candidates in some versions of SQL Server.
RC1 is the most they go, right, Kevin? I haven't seen RC2 too many times.
Not too often, but they have had RC2s. I want to say 2008 had an RC2.
Okay. Wow, that's a while ago, yeah.
Yeah. Let me... That's just pulling up a bunch of SQL Server 2008 R2. Maybe 2012 had an RC2 as well. Now I'm pulling it up just to see. We had RC1. No. 2012 only had RC1 and 0 and 1, and then they went to RTM. So let me pull up where I'm looking at right now. So this is, in case you're ever curious, SQLServerBuilds.blogspot.com. I'll just drop that link right in there. And you have the different editions of SQL Server. You have the different versions of SQL Server. And you can go back to these specific versions and you scroll down all the way to the bottom. You'll see 2008 R2 actually didn't have an RC at all. Or Aaron Bertrand. I know Aaron does one of them and Brent Ozar does another one. This one, I forget. Nonetheless, doesn't matter. They both are very good real resources. So this one, 2008 R2, had no release candidates. That makes sense because that was 2008 R2 was an in-between release. It was mostly BI edition stuff. 2008 only had RC0. So you're right, Mala did not have an RC2. And if we go forward, 2012 had an RC1, did not have 2. 14 only had 2 community tech previews. And we've had multiple CTPs. So yeah, I think I'm the one in the wrong here because I'm seeing CTPs for 2014. Let's check 2016. 2016. Bam. I can declare victory now. So 2016 had RC 1, 2, 3. And you'll notice that they released these candidates. It was like it was about 2 weeks apart, which is a lot tighter than I remembered. But we also see how many different previews they've had. They had previews going back into May of 2015. So they had nearly a year's worth of, actually more than a year's worth of previews that were public and gone through. That there was a lot going on in SQL Server 2016, to be fair. So there was an RC3 for that version. 2017, I'm almost positive there wasn't. I was wrong. So RC2, there was an RC2 of 2017. 2019, we had one release candidate, but a whole bunch of CTPs. This time around, we didn't have many CTPs. It stopped like right about here, but then we've had multiple release candidates. And 2022, we had RC0, RC1, and then RTM. So if we look at 2025, you have CTP 1, 1.5, 2, 2.1, RC0, RC1. So we're moving, and if you look at the release date, if you looked back at those first versions, you were seeing release dates about a year, which would put this 11/19 of 2025. That's right in the middle of Ignite. So it seems like that's a pretty solid guess. However, the fact that we're already in RC1 and that it was mid-September,
Right.
we've got 2 months, which if you followed what we saw for prior builds, you'd be looking at RC2, 3, 4, 5. I wonder if there was a particular reason why RC0 came out so early, and if we're going to see RC2, maybe even RC3, knowing that there's functionality that has been promised but isn't available yet. And now, in fairness, with SQL Server 2022, there was functionality that was promised and just never made the cut. They pulled it out before release and said, "Well, we'll give you that in a later CU." And it took a while for some of this stuff. Wait, Microsoft promises things and not having it at release? Never. Yeah, that's fair. Anders definitely has corrected me there. I retract my prior statement. Microsoft has never done that. Just as they have never taken a minimum viable product that covers 2 of 12 use cases. People come in and say, I need these other 6 use cases that are not covered before I can actually use the product. And then they shrug their shoulders and say, well, nobody used the product, so we're going to stop funding it and stop making it available. That's never happened before either. Definitely hasn't happened in at least 3 weeks. But given the way the tea leaves are going, I would still, if I had money to put on this, I would put it on Ignite. Release at Ignite. The number of RCs prior to RTM is a little weird. It feels like there's going to be a long wait between the last release candidate and RTM, which isn't always the case. You know, we bounced through this list here, and the only thing that I can see in common is you typically have a bunch of public releases. Some of them are called CTPs, some of them are called RCs, and like Anders pointed out there, it seems like about 1 year from first RTP to full release, except in the exceptional cases like 2017 here, where even that was almost 10 months. Their first CTP was 11/16. Although this was not publicly available. You couldn't get access to anything until, I want to say, 2.1 was the first publicly available CTP for SQL Server 2017. Yeah, there are releases prior to the official ones, and these are some of those examples. So these are things that somebody in the know was able to keep track of, but you could never find CTP 1.4 accessible, downloadable from Microsoft at any point in time. That would have been a private installation file that Microsoft would have provided to specific companies to try it out. So good. That's a good point out. Invitation only releases. Yes. Yeah. If you're part of the TAP or EAP or whatever you want to call it at any particular day, basically the set of customers who are interesting enough in some respect that it makes sense for Microsoft to say, here, try this out on your workload because you're some of the weirder workloads, or you're some of the people who will push things harder than your average customer. And so the people there get an opportunity to try things out, get an opportunity potentially to influence program leads and try to nudge things their way. It's a neat program when you're in it. Okay, I need to get my rant face on. Then they go, never mind, we don't want you. That does happen sometimes. Rant face. Okay. This article by Peter Wehner, 13 Reasons SQL Has Got to Go. I'm going to write a counter article, 13 Reasons Why Peter Wehner Has to Go. And I will probably have better supporting evidence than what's in this article. I read this thing before the stream. Look at that, me actually doing show prep. Mala sent this. I know we got it out of Slack. I forget if it was Mark Wilkinson who posted it, but somebody posted it. And when I read, I held off on reading it until right before Shop Talk.
I posted it, Kevin. I thought it was pretty hilarious myself.
It's yeah, you're right, Mala. It is. So Mala actually got to watch me as I was reading it, and when my nostrils pulled up and that sneer of disgust, like every third line, it was amazing. So let me walk through it. Instead of just defaming the article itself, let's actually go through it so that I have a reason for why I hate this thing so much. I'm not going to read the whole thing, of course. You can read it on your own time. What I will point out is the highlights. So everybody uses SQL or SQL, depending on where you're going with that. There's a reason. There's a reason for this. This is an incredibly popular domain-specific language for data analysis. So dominant that many non-SQL projects end up adding a SQL-ish interface. Are we seriously doing a Reacts video? Solomon, have you not noticed that like every episode of Shop Talk is basically me reacting to things? Number 2 is 100% right. Just say no. Hang on, Anders. Before this, I need to point out a law. This is a law. It's a law because I literally called it Fiesel's law, and it is the law. What is Fiesel's law? Any sufficiently advanced data retrieval process will eventually have a SQL interface. I wrote this thing in 2017, and by that point, I thought it was trite, and it was trite enough that I could write it down and say, hey, here's my list of all of these things. You have Hadoop, MapReduce jobs in Java. Well, guess what? The first thing they created was Pig, which is ETL. But then after that, Facebook created Hive. Spark starts with Java and Scala and then added Python. But then we had Shark, which was SQL for Spark. And then we had Spark SQL, which is SQL for Spark. HBase is a NoSQL database on Hadoop. And then they added Phoenix, which gave you a SQL interface to HBase because HBase, the interface for it is kind of not great. How do you access data with Cassandra? SQL. How do you access data with React? SQL. How do you access data with Cosmos? SQL. There are limitations to the SQL, the NoSQL interface that's suspiciously like SQL. One of the few counterexamples at that point in time was MongoDB, but guess what? They have a SQL interface now. So basically, what I'm saying is that I was ahead of my time. One of the most brilliant thinkers who ever done thunked. And so at this point why do people use this? Because it works. I mean, that's going to be a lot of my answer, because it works. SQL's limitations may not be enough to drive it into the dustbin of history. And I will try not to be overly mean in this article. I will be mostly mean, though. Okay, 13 ways SQL makes things worse. Here's the list. We're gonna cover each one. Tables don't scale. And my initial thought to this was, well, define scale. Is 1 trillion rows not big enough? Is like 100 trillion rows not big enough? Because I know people who manage 100 trillion row tables in SQL Server. If you can't manage 100 trillion rows in SQL Server, there may be a reason for that. The relational model loves tables, so we just keep building them. This is fine for small or even normal-sized databases, but it breaks down at truly large scales. Notice that he doesn't define what truly large scale is, because As soon as you start talking about, oh, well, this many rows, okay, well, I found a counterexample. And the reason is you. Good old Johnny Rotten. All right. Integrating sharding into an older open source database. Adding layers to make the data simpler and offer infinite scale, but selects or joins can take vastly different amounts of time to process depending on how much data is stored in the shards. Yeah, congratulations. That's true for every system. Find me a system where that's not true. Find me a hashing algorithm where if you have a finite number of buckets, you don't have vastly different amounts of time to process depending on how much data is stored. Not across buckets, but if I have 1 trillion rows in a bucket versus 12 rows in a bucket, it's a vastly different amount of time to process. Yes, it is. Data may be stored on a different machine or in a different location. Okay, so then he says, well, we should move to something else. If you're going to have everything on the same machine, you're still back in don't scale. If you move it on multiple machines, you're at, well, data can be stored on different machines. Congratulations, son, you played yourself. Inexperienced administrators who start searching across a table may get confused if they don't realize the data is stored in different locations. The model sometimes abstracts the location away from view. Okay, again, that's neither, it is neither necessary nor unique to relational databases. So if your problem is the concept of sharding, very well, that's not mandatory in a relational database. Some AWS machines come with 24 terabytes of RAM. Why? Because some database users need that much. They have that much data in a single SQL database, and it runs much better in a single machine in a single block of RAM.
I'm sorry.
My dramatic rereading of this is not helping the case. But, like, okay, so don't shard, but there's a lot of RAM. Like, what? Okay, yes. Relational databases like having lots of RAM. RAM is also really cheap. It is really cheap to put in a bunch of RAM in a machine and use that bunch of RAM. What's the problem? And is your database alternative going to be more efficient on no RAM? I think this author should probably stick to indexed flat files, Anders says. Funny you mentioned that. SQL isn't JSON or XML native. That's a problem. Well, some SQL databases can encode and decode more modern data formats like JSON, XML, GraphQL, or YAML as native features. But on the inside, that data is usually stored and indexed using the same old tabular model. Well, what else are you going to store it in? You're going to say, oh, well, let's use MongoDB. Yeah, MongoDB, it's web scale. I mean, congratulations, it's like 12 years old. And guess what? MongoDB, there's a reason MongoDB never took off as the great SQL killer. That reason is because every time it tried to, it lost data. Which, interestingly, is not one of the 13 things in here that SQL randomly loses data. It's so weird. But, MongoDB loses data, so that must be a feature. That's probably how it scales better, is it just loses a bunch of data that you probably don't need. Marshalling is a big time sink. This guy read the object relational mapper papers from like 15 years ago, and is like, wow, this is some heavy thinking, some heady stuff here. See, databases store data in tables, but programmers use objects. Yeah, people have been dealing with this for 15 years. We have solutions. Those solutions work pretty doggone well. Use Dapper. There, problem solved. You use Dapper. Or learn how to write a functional programming language. If you use functional programming languages, suddenly you don't have object relational mapping problems. Suddenly those records actually make a whole lot of sense. Your relational database actually gets a lot cleaner. Your code interacting with a relational database. It gets a lot cleaner. But ultimately, here's the real thing. Here's the real deal. If you're using an object relational mapper, let's exclude something like entity framework because, or if you use entity framework, let's say you're doing EF over stored procedures. Let's try to avoid some of the massive pain points of you're doing object relational mapping in the dumb method and stick to you're writing SQL queries, optimizing SQL queries, and getting those SQL queries to work well. What's the problem? You put them in a layer. You put that interaction in a layer. Modern EF is not totally horrible. Depending on what you're trying to do, how you're trying to do it, I do agree with you, Anders. And I would especially say, hey, stuff like EF over stored procedures, I think makes a lot of sense. If you're doing simple, basic simple queries, if you're doing simple CRUD, if you're doing update this row, insert this row, delete this row, and some limited amount of select operations, Entity Framework is fine. It's when you get into really complicated objects and the n+1 problem, where to hydrate this object, you need to then load this list of objects. But to get each one of those elements of the list, you have to load this other list of objects for each one. And then you suddenly have this explosion in terms of how much data you're pulling back. That is a design problem. I would argue it's not an inherent flaw of your object relational mapper. It's a flaw in a design. It's a flaw in you designed it this way and you implemented it this way, and now it's coming back to bite you. And reaping your consequences really sucks sometimes. Nobody complains during the sowing phase. It's all the reaping phase when we all complain. So, yes, point 3 is a big time sink. I don't even think it's a big time sink. Like I said, use Dapper. Write SQL queries. Convert that to objects. Interact with objects. It's not a big deal. So isn't there a way to just leave the data in a format that's just ready to go? I mean, there is, but that typically sucks. SQL doesn't do real time. Nobody does real time. Okay, welcome to rant number 6. This is Kevin, rant number 6. You can mark it in my book if you ever say this is rant number 6. Rant number 6. Real time is for fighter aircraft. If you are not writing software that goes into a fighter aircraft, if you are not writing software where if the time that it takes to operate is above a threshold, people literally die, and that threshold is microseconds. We're not talking milliseconds. We're not talking seconds. We're talking microseconds. We're talking, I'm not sending this over the internet because the internet is too slow. We're not talking, I'm sending this over the network across the office because that's too slow. Real time is literally immediate. It is not 500 milliseconds from now. It is not 50 milliseconds from now. It is not streaming, as Anders points out. There is a specific definition of real time in the sense of how operating systems behave, in the sense of how software behaves, that is different from online. We have had, in our field for decades, these 3 terms. We have had batch, online, real time. They have meanings. These 3 things have a specific meaning, and marketing people have taken real time and replaced online with real time. And those marketing people need to go take a long walk off a short pier. All this means is if the operation goes over a time threshold, you abort the operation. Yeah, or the person dies. So, yes, online operations are essentially, we are interacting directly with the end user, and there is an expectation of fast response. But if you get a slower response, so be it. Batch, you're not really interacting with the user. You're basically saying, I will collect results and then perform an operation when I hit some threshold. That could be a schedule, that could be a certain data size, it could be a number of files, whatever that threshold is. Real time is immediate response. it is measured in time immediacy. And I keep going back to things like microseconds. I keep going back to things like certain number of CPU cycles. You only get so much. And by that definition, SQL OS is real time. I mean, the scheduler actually is a real time scheduler. You get your 4 milliseconds and you're in and out. So you cross 4 milliseconds, you're back. You're getting kicked out. You're off the list. So, yeah, that is a real-time aspect. So SQL doesn't do real-time is a lie. Anders, you're right. Original SQL database was designed for batch analytics and interactive mode. The model of streaming data with long processing pipelines is a relatively new idea. Press X'd it out. And it doesn't exactly match. That I can get behind. If you're trying to do streaming data off of a relational database, it's a challenge. The major databases were designed decades ago. Wow, decades ago. When the model imagined the database was sitting off on its own and answering queries like some kind of Oracle. Oh, look at the product name. Look at that. Look, he made the reference. Sometimes they respond quickly. Sometimes they don't. That's just how batch processing works. Some of the newest applications demand better real-time performance. Again, with the real-time. If you stream from SQL or a relational database, you probably should hang up your architect credentials. Yes. I mean, I would. Where I would go with it is, you have another system. This is the Lambda architecture. There's a reason the Lambda architecture became popular. You have your fast data, you have your correct data. Your fast data, you're trying to get that out as quickly as possible. It may or may not be correct, but at least it's there. Your correct data is batch loaded, is operated on, and runs through the full set of business rules and makes sure that everything feels good. Okay, we've been doing that for a decade. The newest databases designed for these markets put a premium on speed and responsiveness. So which newest databases, you might ask? Because I haven't seen anything other than relational databases in here so far. I'll get to the bottom. If the MySpace devs managed to run MySpace on SQL, your architecture is the problem. Yeah. Now, they also had Denny Cherry there. And Solomon says, and he thinks response time will improve with XML and JSON native storage? Seriously? That's the wild part. Yeah. That, or using YAML, like a YAML parser as storing your data. That's not going to make things faster. Joins are a headache. The power of relational databases comes from splitting data up into smaller, more concise tables. The headache comes afterwards. Reassembling data on the fly with joins is often the most computationally expensive part of a job because the database has to juggle all of the data. The headaches begin when the data starts to outgrow the RAM. Joins can be incredibly confusing for anyone learning SQL. Figuring out the difference between the inner and outer joins is only the beginning. I know there's left joins and right joins, and then you have people like me who say right join shouldn't exist. Every right join can be rewritten as a left join. Finding the best way to connect several joins is even worse. Inner join, inner join, inner join, inner join, inner join. If you're missing information and you need to do a bunch of left outer joins,
best way to connect several joins is even worse. Is he talking of apply, Kevin?
No, he's not even talking about apply because I don't think he's familiar with that. He might be familiar with lateral joins or lateral views from Postgres and MySQL. And a litany of thanks for the ad messages. Yeah, exactly, Solomon. Okay, columns are a waste of space. One of the great ideas of NoSQL is giving users freedom from columns. If someone wanted to add a new value to an entry, they could choose whatever tag or name they wanted. There was no need to update the schema to add a new column. Yeah, and then you start writing your application, and then in your application, you have to write all these checks to see, is name in here? Is name 2? Is name 3? Is name 4? Is name extra? Is name fixed? Is name unfixed? Is name double fixed? Is name triple fixed? Is name triple double unfixed? Because every single yokel decided to use his own naming scheme for each one of these attributes and nobody ever got any conclusion. And by the way, you have data back from 25 years ago when other people who weren't even alive at the time when somebody wrote this system have to manage it and juggle it. Wow, it's almost as though having some sort of standardized application of a set of attributes for an entity actually makes sense. It's almost as though we have had these discussions in the past and have come to the conclusion that structure is typically a good thing. SQL defenders see only chaos in that model. I mean, I did just describe the chaos. They like the order that comes with tables and don't want developers adding new fields on the fly. They have a point. You don't say. You don't say. But adding new columns can be expensive and time-consuming, especially in big tables. Putting the new data in separate columns and matching them with joins adds even more time and complexity. You might be right, Solomon. The author could be trolling with this article. But I'm rolling with it because I'm just going to make fun of the argument. I'm enjoying making fun of the argument so far. And look, what I will say is that there can be issues in terms of data modeling. You have to get that data model right. What I will also say is, yeah, in a system like Cosmos DB and MongoDB, whatever, where you have that freedom to make all of these column changes, you now have the responsibility in every single one of your applications that you have to manage this information. You have to understand what attributes exist, and you don't have constraints. You don't have ways of confirming that your data is correct, that your data remains correct, and that the data that you believe you are accessing is, in fact, the data that you are accessing. None of that stuff really exists when everyone gets willy-nilly access to devising for a single record what the data model looks like. This is the Excel spreadsheet design, where in an Excel spreadsheet, I could put anything in any column. Now try working with that in any sort of automated fashion, and you figure out real quick why it doesn't make sense to let everyone go all willy-nilly. Optimization only helps sometimes. Database companies and researchers have spent a great deal of time developing good optimizers that take apart a query and find the best way to order its operations. There are limits to what an optimizer can do. If a database administrator submits a complicated query, there's only so much the optimizer can do. Okay, give me the alternative. The alternative world where arbitrarily complex queries don't exist and every single business requirement can be met with simple queries. Give me that world. Tell me the story of how that is ever possible, because it's not. You switch to MongoDB and then the business person asks a question. Well, what was our 3-month rolling average in terms of product sales? Well, I don't have that in a table, so I can't give that to you. Okay, you're fired. Find somebody who can get it. Or once you start getting to, well, I like that information, but I also need a 6-month rolling average. I need a 12-month rolling average. And by the way, I also need to be able to filter it over these 7 criteria. And when I told you 7, it's actually 12 because somebody else gave me these other ideas. You start getting levels of arbitrary complexity. I mean, this is why we have data warehouses. This is the whole impetus behind data warehousing. And data warehousing projects often fail because they are incredibly complex. It is not because of the relational database. It is because business problems are very complex. Your tooling can help you sometimes, but it is not going to turn complex problems into simple. The marketing people will claim it, but then you start pushing the marketing people with real world examples, and they're like, well, you have to design it differently. Yeah, congratulations. If your answer is you have to design it completely differently, then you're not any better. Okay. Denormalization treats tables like trash. Mala, I'm going to mute you here. There we go. Sorry, you were coming through with a lot of feedback. But got you muted. You're welcome to unmute whenever you want to jump back in. In the meantime, denormalization treats tables like trash. I agree. 100% agree. Don't do it. Developers find themselves caught between users who want faster performance and bean counters who don't want to pay for the hardware. Again, where in your magical database system are you going to fix that constraint? A common solution is to denormalize tables so there's no need for complex joins or cross-tabular anything. All the data is already there in one long rectangle, which I just talked about data warehousing. In many respects, that is the intent of data warehousing, but data warehousing does it in very specific rules. This isn't a bad technical solution. Usually it is. And it often wins because disk space has become cheaper than processing power. True, but correct data models are better. Denormalization also tosses aside the cleverest parts of SQL and relational database theory. All that fancy database power is pretty much obliterated when your database becomes one long CSV file. I mean, again, I'd say the answer is yes, but how does that differ from anything else? And don't do that. Don't do that because there are specific needs. You introduce all kinds of problems. Go talk to the MongoDB people, or actually not the MongoDB people, the people who use MongoDB, and ask them about some of the challenges of updating data. Updating data across large numbers of documents and making sure that they get it correct.
Correct, Anders. Totally agree. Nice.
Yeah, and then look up Jepsen, because after you've done that, then all of those nice distributed database systems, you say, wow, I don't want to store any real data in there. Bolted on ideas can wreck your database. There's a plastic surgery joke just right at the top here. Developers have been adding new features to SQL for years, and some are pretty clever. It's hard to be upset about cool features you don't have to use. Okay. On the other hand, these bells and whistles are often bolted on, which can lead to performance issues. Some developers warn you to be extra careful with subqueries because they'll slow everything down. Those developers are terrible. They are terrible developers. Do not listen to those developers. Subqueries are not the cause of slowdown. Bad query plans come from poor queries. Subqueries may be a cause, but they are not the cause. They are not always the problem. This is absolutely backwards thinking. This is, well, I saw a subquery was bad and replaced it with this other thing in this one specific circumstance, so all subqueries are bad. No. You have to understand. Oh my gosh, I'm missing stuff. I didn't even see who all this stuff that was writing. So I've been staring at the screen at Solomon's last comment, haven't even seen all the stuff that Andrews pointed out. Another clueless dev. He's written more than 20 books, Mala said. Yeah, Mala was just shocked when I pointed that out at the bottom. Too many of these problems are benefits that allow the system to scale and be reliable. You're right. I can sum up this entire article. Use the right tool for the job. I mean, yes, but then the right tool for the job is relational databases. Someone get Kevin his blood pressure medication. No, I'm enjoying this. I am enjoying this a lot. I don't know. Hopefully not all flushed red, but basically, point being, if you can prove that this subquery was the thing that slowed something down, and when I say prove, look at the query plan, explain how in this query plan, what the optimizer did, the subquery was the immediate cause, and there is an alternative that does not cause the same issue. Cool. Perfectly fine. If you then draw the conclusion that subqueries are the problem, no, you are the problem.
Mm-hmm.
Others say that selecting subsets like common table expressions, views, or windows overcomplicates your code. Again, those people are dumb. Do not listen to those people. Do not listen to the people who are saying, oh, you can't use common table expressions because they're so complicated. No. Learn the product, learn the tool, know how to do your job. You are a developer. You are getting paid to develop. You are getting paid to develop in SQL. You should know the language. You should understand the language. If you are not getting paid to develop in SQL, it is perfectly fine not to understand the language. But for these people who are getting paid to develop in this language, they should have the bare minimum professional capability and the professional willingness to do a good job. That's my problem. Yeah, common table expressions make life easier most of the time. A lot of the time, yes, but then they have the same performance profile as subqueries. In Postgres, you can have materialized common table expressions, and that can change the story a little bit, but in SQL Server, it's the same performance profile. So what's the problem there, Jake? So the author's complaints aren't totally unfounded, but perhaps stripped of context, nuance, and respect. Some of these are totally unfounded. Some of these are reasonable. I think this is it's trying to be hot takey is what I think the problem is. So SQL syntax is fragile, yet too fragile, yet not fragile enough. I mean, this is the type of hot take nonsense that I hate. And what it comes down to is, oh, well, sometimes I just want like select group, the name group, the column name group. And, oh, well, different database platforms don't like that. Okay, that's fair. Reserved keywords. I mean, I want to name my variable void. Why can't I name my variable void? Why does that break my compiler? Why is my compiler giving me an error? It's because that's a reserved keyword. Congratulations. It's not a SQL problem. And to make matters worse, SQL injection. Injection attacks aren't a SQL problem. There are XML injection attacks. There are JSON injection attacks. There are Excel injection attacks. You can actually have an injection attack using Excel. I've done it. It's cool.
What's the last line, Kevin?
Excel.
Oh, Excel injection attacks.
Yeah, as in spreadsheets. Uh-huh. Yes, as in you open up a spreadsheet that then performs malicious code. Uh-huh. Everything in which you have the ability, basically, if you cannot separate code from data, if you cannot separate what is code, what is data, you have the possibility of an injection attack. SQL injection is the most popular because it is the most common. It is the most common because that's where everybody keeps their data. It's like the old aphorism about why did you rob that bank? Well, it's because it's where the money is. Yeah, I'm going to use that injection attack on the database because that's where the data is. Let's see. I don't understand this. So let me go on and write an article. I mean, yeah, there's a little bit of that, Mala. He's not wrong on the different standards for using reserved keywords. Yes, and also for things like backticks versus brackets. There are some things in the SQL standard that are not specialized. They're not specified, and different products will have different ways of doing it. There are some things like the apply operator. When Microsoft introduced it, it was not part of the standard. After they introduced it, it became lateral join or something like that. So in Postgres, it's a lateral join. In SQL Server, it's apply. They're the same concept. It's just that Microsoft released it prior to this becoming part of the standard, and they're not going to rename their feature because a bunch of people wrote code based off of it. So you deal with it, which is the problem. Can't PDFs contain escaped code? Oh, absolutely. Anything that interprets code and does not have a strict way of structuring data, you can have an injection attack. This is why the solution for SQL injection, or really any type of injection attack, is libraries in which you're not trying to escape out the data. You're not trying to put brackets around or put ticks around the data, but instead are actively separating the code from the data. And it's only that kind of a mechanism, like SP execute SQL allows, that will actively prevent SQL injection. And it's the same thing for any other type of injection attack. There are large language model injection attacks. You can have an injection. We actually talked about this not too long ago in Shop Talk, that, yeah, you can have injection attacks on anything as long as you have one way of sending in code and data at the same time. Okay, not everything is a table. Social networks, hierarchical data, many scientific phenomena are labeled with graph or modeled with graphs. Well, guess what? You can describe a graph as a relation.
Yeah. Graph
Nodes,
is a relation.
yeah.
Yeah.
Yes, a graph is a relation. Yes.
Yeah.
Nodes are relations. Edges are relations. These can be stored in tables, but doing anything more than the simplest query becomes complex.
Sure does.
Yeah, it can. But then do the same thing with a graph database
Right.
without the nice API around it, without like shortest path calculation as a function. Write your own shortest path calculation. You find out, oh, your graph database is also kind of complex. And then there's spatial data in 2 or 3 dimensions. Wow. Wow. A third dimension. What'll scientists come up with next? You
At
can.
least time series data has only one major axis.
Ugh. This went from, yes, he is technically correct about, yeah, this is graph data, but then you can store the graph data as relations. And you can't store all relations as graphs. It doesn't work out very well.
Mm-hmm.
But then spatial data, time series data, it's data. It's data with attributes. Multiple dimensions. Multiple dimensions. If only we had some capability in relational databases to have multiple dimensions. Tables, though, only have one axis for the rows and a subordinate axis for the various columns. Multi-dimensional calculations like distance isn't easy. Come on. Come on. I'm not even giving this the respect of an answer because it's dumb. It's so basic of, oh, well, your table's just a square, and because it's just a square, it don't got no cubes, and because it can't got the cubes, you can't do the cube things with it. What are you doing for modeling? How? This is actually hurting my head at the moment. I'm trying to figure out what is the argument here in a way that is not just me snidely ripping on what I hope is a caricature, but there's only 2 paragraphs of information, like actually 1 paragraph of information here that is not explanatory, it is not helpful in laying out the argument. It's not doing a good job. SQL is not so standard. That's fair. They're, like we just talked about this. I think that's a fair point. Spoilers. Neither is anything else. Once you have more than one product in the market, there's no standard. Graph databases, there is no graph standard. There is no graph language.
Mm-hmm.
There is Neo4j and its graph language, but then Giraffe had a different language.
Yeah.
And like any other graph platform, Neptune has a different language.
Yep.
There is no common language, and most of those products just disappear. So there's really just Neo4j.
Right.
There are better options. Oh, here we are. We're getting to the end, everybody. We're getting to the end. What are the better options? Peter, you have spent dozens of paragraphs regaling us with all of the problems of relational databases and how it's all so terrible. What is better? GraphQL. Are you seriously telling me that GraphQL, which is a language, is not a graph database language? It is a language for API access, that this is superior. GraphQL is an access language. It is not a data platform. So where does your GraphQL operator, where does your application get its data, store its data? Oh, well, we'll store it in JSON. I have a bridge in Brooklyn that I would like to sell you. More concise. That is already a lie. Flexible. That is not a lie. It is flexible. Whether it's more flexible, I don't know. I would say that's debatable, and probably no. Readable, more readable. Again, if you show me the GraphQL for complex business logic, I'm not talking about give me users. I'm talking about give me dozens of attributes about different users, aggregate this data over time, operate on this data in slices, and show me aggregated metrics of that sliced data, I guarantee you it is not easier. It's not more readable. So get off of that. Hierarchical data is naturally supported. Yeah, that is true. But that's a small subset of all types of data. There are several good options for searching NoSQL databases. Key value stores. Just look for matching nodes. Some, like the MongoDB query language, imitate the popular JSON standard. Yeah, I spent a lot of the time railing on MongoDB for good reason. That was the hot stuff from like 2013, 2012, 2011. Here, let me go to dbengines.com. We're going to go to dbengines.com. Remember, MongoDB was the hot name like 12 years ago. Where is MongoDB today? It is on the list number 5, I saw. So let me scroll here. Number 5. So, congratulations. It is much less popular than 4 major relational database platforms. Okay, then what comes after that? Relational database. Redis, caching, key value. DB2, Databricks. Databricks is a bunch of stuff. Elasticsearch. Now, Elasticsearch is the other thing that he mentions. Then SQLite, Cassandra, by the way, that's mostly SQL interface. MariaDB, SQL interface. Access, SQL interface. So you look at the top 15 here. I just picked 15. Like 16 is SQL, 17 is SQL, 18 is a search engine. So you scroll down further and you get basically the same story. Relational, document, relational, key value, relational, combination, but this one I would not consider anywhere near relational. This one, sometimes relational. Relational, multi-model, but still SQL. Relational, multi-model, not SQL. Relational. Gee, Peter, I wonder why everybody's using these things if Mongo is so much better. It's almost as though Mongo has major built-in flaws. It's almost as if they are not a general purpose data store, but instead are good at specific capabilities. And you can go through half of this list here and have the same problems with Mongo. Tell me about which shard something is on. Tell me that you can have no problems with balance. Tell me that you have no problems with data loss. By the way, data loss doesn't even come up in here because relational databases actually keep their data. Wild stuff, that. And then document-centric solutions like Solr or Elasticsearch. I mean, yeah, again, that has a specific use case. There are products that have specific use cases, and if he says you should have 25 different databases for 25 different use cases, no, because that's dumb. Because now you don't have one language. You have 25 languages on 25 products, and good luck trying to integrate across all of these. You have now given yourself an order of magnitude more problems to deal with. Basically, the article is dumb.
Yep.
And
That's
most systems,
a good summary. Yeah.
I think that is probably the best summary. So most systems also do not need Facebook-like level of scalability. You're absolutely right. And guess what? Facebook also developed, like I said, they developed Hive, which is SQL on Hadoop. They have these sorts of interfaces. They still have their developers writing in SQL. Their business analysts write in SQL. Why is that? Because everybody knows SQL, because it's a pretty doggone good language for data-specific operations. It is a data-specific domain, a data-oriented domain-specific language that is really good at its job. And relational databases are really good at their jobs because they're very good at retaining and providing access to data at pretty good rates and pretty good levels of consistency and pretty good operations. They're pretty good across the board. They're not perfect. Nothing is perfect. I'm trashing the alternatives here because the alternatives are dumb. Mm-hmm. The alternatives are, well, in this one little avenue, this thing is better. Yeah, Elasticsearch is good for documents. If you are doing document operations, if you are vectorizing data, if you're storing vectors of data, or even if you're doing keyword lookup operations on large text data sets, Elasticsearch is great. If you're trying to store metrics, performance metrics in Elasticsearch, you're doing it wrong. It is bad at that. Elasticsearch sucks at aggregation. And if you try to tell me for a moment that Elasticsearch is more readable than SQL, I will kick you out of this stream. But unfortunately, we are at the top of the hour. So we are going to wrap things up. I spent probably a little bit longer ranting about this than I expected to. But I enjoyed it. I enjoyed the rant. Hopefully you folks did as well. Quick note that tomorrow we have our business intelligence, data science, everything type of meeting that is mastering storytelling with BI. So check that out, meetup.com/tripass. You can come straight here tomorrow, 6 p.m. Eastern time, and you'll get that for tomorrow. So with that, we are going to wrap this up. Part 2 to come in 2 weeks. Now, I've gone through the full rant. So we're good. That has been a very cathartic experience, and we're going to wrap things up for tonight. So until we do see each other, either at Shop Talk or another TriPass meeting, everybody, take care.
Have a good night, everyone.